Hi, this is Professor Fernandez working on class note C in lesson 14. This is going to be a very quick video because I'm not asking for much in this example. We're using the running example that we have in the previous two examples and videos. But what I want to just show you how to do, we've before in the previous videos converted this to a system of three equations, and we also converted that to a matrix representation. And there were a few numbers here that you can go back to the previous video to see. And then now what I want to show you is how you convert the initial conditions to this matrix representation form. And that will effectively complete the illustration of how you would convert an initial value problem into this matrix form, right? So that's kind of the objective of this example. Okay, so if you remember from the first video, the way that we converted this system into the matrix form was we introduced a substitution. X1 equals y, x2 is y prime, and then x3 is y double prime. And I should have put here the of t, so I'm going to move this a little bit, excuse me, because that is going to be important for this example. So it's x1 of t, x2 of t, x3 of t, and then y double prime of t, y double prime, y prime, and then y. Okay, so how am I going to use that? Well, the vector valued function that we assemble from these three x's looks like that. So let's now look at what happens if I look at vector x of 0. Okay, so that would be plug in t equals 0 on the right, and that leaves me with three quantities. And then I'm going to use this substitution. So I'm going to say, oh, x1 of 0 is y of 0. So that comes from this. Okay, and then I'm going to say, oh, similarly, x2 of 0 is y prime of 0. That's the second equation. And then x3 of 0 is y double prime of 0. That's the third equation. Great, so now I can go back to this specific example up here, and I say, oh, I'm given information about y of 0, y prime of 0, and y double prime of 0. So I am just going to put that information down here and say, this is y of 0 is 1, y prime of 0 and y double prime of 0 are each 0. Okay. So therefore, my conclusion is that the initial value of the vector valued function x of t is the vector 1, 0, 0. Okay. So I think we had in the previous videos written down the matrix representation of this, and I think it was, let's see, 0, 1, 0, 0, 0, 1, and let's see, minus 3y, so minus 3, and then minus y prime, minus x2, and then there's no x3, and then plus 0, 0, e to the t, right? And I'm just going to scroll up a little bit, make sure I got those numbers correct to the previous notes from the video. Yep, so there they are, minus 3, minus 1, and 0 for the last row. So this is now the complete vectorial form of the initial value problem, right? All of this corresponds exactly to where we started, y triple prime plus y prime plus 3y equals e to the t, and then the initial values y of 0 is 1 and y prime of 0 equals y double prime of 0 equals 0. So you can see the correspondence here, right? These initial conditions through the substitution x1 equals y, x2 equals y prime, x3 equals y double prime turn into this initial vector. And then this ODE, one single third order ODE, turns into this system of three first order ODEs. All right, so that's it for this video.